And we are live. All right, everyone. Welcome. My name is Michael Wolf, and welcome to this month's edition of the Food AI CoLab. And I am very excited about this topic because this is one that I've been looking at very closely this year. And quite honestly, I think it's one of the most important areas of food that we have. It's where it all starts. And I think it's where AI is probably getting more traction than a lot of different spaces with regards to the food value chain. And so we have a really great conversation ahead of us. And to tee up our speakers, I'm just going to let you know what their titles are, but then let them introduce themselves. We have with us Tim Bessinger, CTO of Heritable. Hey, Tim, how you doing, man?
I'm doing great. Really excited to be here and looking forward to the chat.
Just like 30 seconds, tell folks what you do for Heritable.
Yeah, absolutely. I'm the CTO of Heritable and I lead the AI and computational efforts. So we're doing a lot of work in the plant genetics and transcriptomics improvement space. So things like finding the genes that are controlling important traits, finding which genetics matches which environment and which management types, and all of that on Heritable's efforts falls under my oversight. Then we also yeah. Can I tell you more about Heritable now, or should I give more of that in a minute?
Yeah. How about in just a few minutes, we'll do a little presentation for those in the audience. We have just maybe like 3 or 4 minutes, up to 5 minute presentations by each, just so I think you could get the idea of what they're doing and share a little context. But we'll do that after quick intros. Charlie Anderson, welcome as well, CEO of Burrow. Tell us really quick about you and Burrow.
Yeah, awesome. Well, burrows are, you can think of them as Disney's Wally for work outdoors in a version 1.0 format. So people scale robots drive around alongside people in the most labor intensive areas of agriculture. And then for me personally, I grew up on a working fruit and vegetable farm. My family has a farm and also a construction business, and I was always running machinery growing up, and kind of got obsessed with the idea of like robots should be doing the things that I don't want to do. And so I got out of business school and I went to go work for a company called Fiat Industrial, which became Case New Holland, and spent about 4 years there looking at autonomy companies for the company to buy before I realized I didn't really want to jump in. And so in 2017, I quit my job, found a couple of co-founders, and we went from, at this point, 3 guys and a dog working at an unheated barn. Today, we're around a 60-person team, and we're selling about 25 or 30 robots a month. And we have about 600 plus running. So that's a bit about me.
That's great. And as everyone can see, we're going to have a wide-ranging conversation spanning things such as how AI is manifesting itself in terms of things like automation and robotics to help us and help farmers on the field, to how AI may be accelerating or will be accelerating plant science and enabling kind of ways to bring more sustainable agriculture to us. And so I'm really excited about this conversation. I do encourage folks in the audience, if you have questions, to throw them in the chat there. That's what I'll be looking for them. And I will ask them throughout the course of the conversation. So, and if I don't get to it right away, be patient. But let's dive into some quick presentations so you have a better understanding where our speakers are coming from. I'm going to start with you, Tim. I'm going to bring up your presentation here on the screen. Great. And everyone can kind of see it. So yeah, tell us a little bit more about Heritable.
Wonderful. Thank you. So Heritable started at Google X, which is Google's moonshot factory. And there we were focused on, for several years, the question of how can we take all of these breakthroughs that have been happening in AI and apply them to agriculture, and specifically apply them to plant genetics. So I was a plant breeding professor for a long time. And in plant breeding, we've been using all sorts of statistical approaches, and that's evolved into machine learning approaches over time to figure out how we can improve plants so that they're better. But there's really a revolution going on right now. And it's, as you can see on this slide, allowing us to make plants programmable. So overall, right, the pace and cost of crop improvement is really putting the food system at risk, and it's limiting the size of the ag industry. So a really interesting fact is there's literally billions and billions of dollars of investment into plant improvement every year across the industry, but almost all of it goes into corn and soy, and they get 1% to 2% increase in genetic performance every single year. So this is not very effective to spend so much money on making a plant 1% more productive. And it's almost entirely on yield. There's all sorts of other things that our plants can do. they can taste better, they can be more nutritious, they can grow in better environments. But nope, let's focus on yield in Iowa. So this can be improved. The ways that Heritable are doing that is by developing a biotechnology and a predictive breeding stack that really lets us program plants, and it makes us develop digital fields. So I'll get a little more into that right here. We have this revolution. There's so much data right now. There's data coming from the sky every single second. Tractors are collecting lots of things about the fields that they're running through. We can sequence DNA basically for free compared to what it used to cost. We can sequence other things. We can sequence RNA. We can look at proteins, all this stuff. And now with AI, we have the tools to bring it all together, to bring this really disparate data types together into single models, individual approaches that break down what's doing what to make the plants perform as they are. So here's a little preview of what we really do at Heritable. We really have two products. One of them lets us do performance prediction of plants, and in a way never before possible, match specific genotypes to specific locations. So we could do product placement down to a 10-meter resolution for any position in the world. We take a bunch of training data, which are past trials that have happened. And then we build a model that lets us say, okay, which varieties are going to perform best where? Which one matches Iowa, which one matches California, which one matches Brazil, which one matches South Africa, and so on. And that's based on the weather conditions, the soil conditions, satellite-based embeddings that we extract from satellite data, and also the management of the farm itself. Then we're also doing a lot in the biotechnology world, where we're not so much saying what is the best plant for a certain environment, but we're saying what is the best genetic makeup for a certain characteristic. So on the bottom, you're looking at a breakdown of finding the specific, precise genes that are controlling a trait that matters. You name the trait, we have models to figure out what genes are controlling that trait. And then we have DNA language models that let us design where should we do edits for those traits if we want, for those genes, if we want to change how the gene is expressed. We have here a platform we've developed that lets us dive in and lets us figure out if I want to take my training data and expand it to a whole region. I could do that really easy using Heritable's platform, or I can zoom in on the right side and figure out across the chromosomes. So every gray line here is a chromosome, and the little colored bars are the genes that we've identified that are controlling a particular trait based on our models. So just to close this out and not take forever, we're all kind of scared that the AI future looks like this, that we lose our ability to think, to create. I get so terrified when I hear folks on podcasts talking about AI agents that are going to shop for us. I don't want an AI agent to shop for me. I don't want to become just a robot doing exactly what I'm told. So is this the AI future? And at Heritable, it's really not. Here is a video of my two co-founders, Davide and Brad, collecting the data that make our models work. We are out there in the fields getting really unique data sets. We have to move really fast on this one because we're extracting RNA from the corn roots that you see in this video. Really quality data is what drives our models, and really quality data today still requires humans, and humans are making those decisions and humans are benefiting. So there's a quick overview of Heritable, and I can't wait to hear more about Burrow.
Awesome. I have so many questions, but we're going to wait on these so we can have Charlie show a little bit of what he's building as well. Thank you for that, Tim. Charlie, do you have some slides for us?
Yeah, give me 1 second. Let me share screen. 1 second. Yeah, so a bit about us. Can you see my screen okay, hopefully?
There we go. It's on stage now.
Awesome. So I'm going to start with kind of a little bit like I guess a problem statement. So I think so robots are really hard. And if you actually, there's kind of this weird irony in this space. There are something like 8 to 9 million robots in manufacturing and warehouses globally. There really aren't a ton outdoors yet. So we're kind of on this weird point in time where there's so much potential. I think with I think robots in warehouses are mostly hardware plus software. Robots outdoors are hardware plus software plus AI. So truly like physical AI handling dynamic things. And there aren't a lot of big winners there yet. And then you get into agriculture specifically. And I think Tim was maybe touching on this a little bit. The irony of agriculture as it relates to things like autonomy or perhaps plant genetics and so forth is that actually let me go to this slide to show it more effectively. Half of farm revenue is crops and half of farm revenue is livestock. And on the crop side, a large proportion of crops are actually ironically fed to livestock. So if you look at on the crop side of things, 2/3 of farm revenue is corn, wheat, and soybeans, and the other third is specialty crops. And so you've got a third of crops that are specialty crops, but they're like 90 to 95% of labor. And so the irony of autonomy or of the irony of robotics as it relates to agriculture is how do you build a big business in agriculture where labor does a million difficult to fully automate things within a lot of niche crops. And so to me, what that means is there's tons and tons of potential today, but there aren't really any big outdoor robotics companies yet. And I think agriculture is a great place to start, but nobody's reached the hundreds of millions of dollars in revenue and tens of thousands to hundreds of thousands of subs running yet. And I think the reason for that is that to build a big robotics company outdoors, you've got to be able to work safely in your people. You've got to be able to do multiple things because you've got winter, spring, summer, fall, and each one of those seasons have different jobs you have to do. Whereas if you're in a warehouse or a factory, you can do the same thing year round. And then there's this terminal robotics deployment. And to me, like you deploy the military to Iraq, it's very kind of like heavy, bureaucratic, kind of cumbersome term. And I think for most human beings that work outdoors, you use a thing, you run the thing. Like it's like a lighter thing. And then finally, when you're outdoors or working near people, you've got to be able to work in GPS enabled and GPS denied areas. And so these are, it might be the four of the reasons why there aren't any big autonomy companies yet. And our product is kind of an answer to that problem statement. So we build, again, I describe it as Disney's WALL-E or Star Wars' R2-D2 for work outdoors in a version 1.0 format. And how does something like Disney's WALL-E actually start? To me, it probably starts as a vision-based ground vehicle that drives around alongside people. It's very data acquisitive, and it does the 5 most ubiquitous jobs to be done outdoors, which in our case is, and I'll skip through this slide, in our case is hauling things, towing stuff, mowing, spraying, and patrolling. And so these are the 5 things that each one of our robots are able to do. Today, we've sold about 600 to date. And I'll go over and show something live now. We've shown about 600 to date. This is where our fleets run globally. So we have about 375 in the US. We got about 170 or so in Australia, give or take. And what's really cool about these, just tactically, is you can see them in real time as they run. So what you're seeing here, this is just a little bit of depiction of the fleet. And what we've discovered is that I think that it's really difficult to make a system learn without letting it make a lot of mistakes. And so we've built something where we're able to run a ton of miles and a ton of hours very quickly in a lot of settings. And when we make a mistake, because we're pretty small, we're moving slowly, and there's a lot of redundancy in the system, we can safely make a mistake and learn. And the implication of that is that today, we have about 120 years of autonomous operation. So literally, I think it's 850,000 hours of autonomous operation. And we're starting to reach the point where we truly have general purpose mobility. And the implication of that, to me, is that we've started in a really niche space. And now as we're approaching general purpose mobility, we're starting to reach a point where we're an autonomy company starting in agriculture, not just an ag tech robotics company. And when I think about where this ultimately goes, I think like a robot like Disney's WALL-E starts in grape fields, it starts doing, hauling grapes around. Over time, it starts doing a broader set of things like towing and mowing. And ultimately, what my team is trying to own is movement. So we're trying to be the movement layer that does work outdoors. And I think as dexterity and manipulation and data and detection goes into agriculture and construction and industrial settings, I think a lot of those types of technology are going to ride on burros. And Burroughs again are trying to own mobility as a layer. So that's a bit about us.
Wow, that's a great presentation. I love that visual of all these different kind of a bird's eye view from the different robots around the world. That's really, really cool.
I think robots are they're just really fun things to work on too.
So you talked about owning the mobility layer. It's, there's lots of other robots I follow across food value chains. Like there's probably 10 sidewalk delivery robot companies, but they're largely gathering views of people's sidewalks and maybe bike lanes, and then maybe homes and food. Yours, from my understanding, is largely in rural and agricultural settings. That seems like very different data sets. I know that like a person's in front of me, there's an animal in front of me. Is your data set that you're gathering, that you're moving towards general mobility, kind of more leaning into rural farm-based visuals, or can this be transferred to like, hey, now we can push mobility into neighborhoods and suburban areas? If that makes sense. I don't know if I'm...
Yeah, no, that's a fantastic question. So for a long time in our operating system, we have had effectively like flavors of fruit you can select. So like which model do you run depending on application area? And then we are starting to reach a point where, when I'm talking like scene segmentation, so perception of the environment as you run, and we're reaching a point where you can have one model that works across all of the environments because it's been trained on many different things. And so my impression is that, in time, our mobility could very much go into, I don't know, sidewalks, depot yards, like all those types of realms. And at the same time, I think if you think about, it's actually at times easier to work in a man-made, heavily structured environment like a sidewalk than it is to work in a outdoor, highly variable, semi-GPS denied sometime thing. And there's like funky problems, like, I don't know, reflective water. Like, do you drive through it or not? Well, is it like a really deep pond or like an irrigation thing? Or is it reflective water you want to drive through it? So I think my impression is that ultimately we become much more generalizable, and that the sidewalk robotics, like I'm never going to go into sidewalk robotics. Don't get me wrong. That's not a realm I think I probably go into. But there's nothing that precludes our robot from going into those types of settings technically.
I want to jump in on the generalizability
Sure.
part, because right at the beginning, when you started talking about how all of the specialty crops have how specialty crops have not that much market, but so much of the labor. And that is so parallel to what we see in the genetics side, is the lot plant improvement can't be done for small crops in a traditional sense. And one of the breakthroughs we have right now is that taking models and expanding them so they're not just focused on corn, not just on soy, but going wide is possible. And I see you guys at Burrow are doing the same thing. Hey, we can make a robot that's going to work in a grape field, or presumably a orange field, or I don't know. I can't say what fields, but a lot of different types of spaces. And that is one of the big changes that's coming, is we can use new tools to work across everything. And I think it's exciting.
Yeah, it seems like it's interesting because you guys couldn't be more different in terms of, one, you're working on building new types of plants, kind of using these building blocks of genetics, and Charlie, you guys are putting together a robot that moves through the physical world, a machine. But what I'm hearing is the rise of more advanced AI systems, and the lower cost of the AI systems are pushing both of you guys to go more widely into areas that before may have been neglected because they're just smaller overall markets.
Right. Charlie, correct me if I'm wrong, but combines in cornfields have been driving themselves for 20 years, right? 10 years at least?
Totally. Yep.
Yeah.
RTK GPS for a long period of time, for sure.
Right. And so that's what's different, is you don't need $1 million combine for one crop. You're doing probably a lot less than $1 million per robot if it's for a grain
Yep.
field.
Yep. Totally. Yeah, I think that I guess I guess there's the book The Innovator's Dilemma by Clayton Christensen, which kind of it's like talks about like sustaining versus low end or new market disruptions. And I think about something like a combine. I think again the irony of this space around like machinery that's used in agricultural settings is the large companies like John Deere and CNH and AGCO that make combines make all of their money selling really big stuff. If it's really big, there's no labor in it because the labor is doing, you're sitting in a cab and you're doing 2,000 acres of harvesting a day, and you're pushing buttons maybe, and the thing's largely driving itself, but there's no labor in that. All the labor is in the small stuff. And so if you're John Deere, your biggest and best customer wants a bigger combine with a nicer cab. They don't want a little robot that drives around replacing labor. That's not the market you're going after. And so I think that there's a lot of the problem space that exists in specialty crops, I think, can be extensible into a lot of other areas to get into a larger market. I suspect in genetics, certainly in autonomy. And so there's this kind of, but then again, there's this irony that the big markets today with a lot of machines have no labor. The small markets without a lot of machines have a lot of labor. And so how do you build a big business, with
Yeah.
that as a domain?
Well, yeah, it's the exact same thing with genetics. I mean, I showed our platform a minute ago. It's the exact same model underneath, whether we're doing it for, corn or pine trees. It's the same. And that means the labor is so much lower. It's much more scalable. And that's exciting.
We already have questions flowing in, and I will get to them, but I just want to ask a few more questions. And so, Tim, I think we had a chat before this that you talked about how you work within the ecosystem. And when I think of genetic kind of uh, manipulation or kind of advancement with regards to food, I oftentimes think of things like CRISPR. We talked about pairwise, for example. And so, people may know of pairwise because they're saying they're going to do like a new CRISPR based mustard green that is less bitter, and they were able to do that much faster because they didn't have to go through all the animal plant breeding over a decade or two. But you guys work with folks like this, so maybe to give people the context, how do you work within the ecosystem where your AI tools may help someone like a Pairwise bring a product to market faster?
Yeah. So there's two answers to that question, and I need to give both of them.
Sure.
The first part of the answer is we do not just do CRISPR. That's been a major difference between us and some of the other startups out there in the plant genetics world. Is CRISPR is an amazing tool, and it's part of what we do. But people forgot about breeding at some point, and there's this sense that breeding is old fashioned, and that couldn't be farther from the truth. So we can use our models to make breeding decisions sometimes 4 times faster than could be done without them. So if you can dump the DNA and the RNA into a model and know immediately what is the best performer, then you can breed so much faster. If you think about a pine tree, it takes 15 years to do a generation of pine selection. Um, that's because you have to wait until the tree grows to see. So that's one side of our company, is working on breeding questions, and some people like to say traditional breeding, or um, I hate that word. I call it advanced breeding, AI breeding. Call it what you want, but the revolution that's happening on modeling is very much applicable to breeding. So there's one part.
Yep.
The other part is identifying genes that can be edited with tools like CRISPR. There's a whole portfolio of tools that are available to make modifications, whether it's a traditional GMO or if it's a non-transgenic CRISPR edit, or even editing free approaches to mutagenesis for getting specific base pairs changed. Um, all of those tools are yeah, things that sound amazing, but if you don't know what you're going to edit or modify, they're useless. Um, so molecular biologist, it's becoming a commodity to do CRISPR. Just here's the protocol you follow, and you've done an edit. But corn, for instance, has 2 billion base pairs. Which of those 2 billion base pairs are you going to edit? And that problem is still very difficult to solve, knowing, hey, here's something that really should be edited to get the result that you want. And so that's where we come in, is driving those decisions and interpreting field trial data to say, oh, like there's where I should place my edit. And so with folks like Pairwise you used in your example, where we fit in that kind of relationship is the intelligence behind making that decision. And then we work together on, a fee structure like any company.
Got it. So I'm going to ask a question from the audience. Tiff Graham asks, and this is for you, um, Charlie. Do you partner with other agricultural machine companies like John Deere, or do you consider yourself your company, not in the same category? How would you kind of answer that?
Well, I'm going to give kind of perhaps a funny response first, then I'll make more serious ones. First, I think there are 4 great brands that do work outdoors with machines. There's Deere, there's Cat, there's Bobcat, there's Toro, and there's no great animal brand for autonomy companies yet, in my opinion. I think the Burrow kind of has all the hallmarks of that style, creating a category of things with a great autonomy animal brand for work outdoors. On a more serious note, when I think about a Deere, a CNH, a Kubota, we certainly sell through some of their dealerships today, and I think that because our product is, I guess we are sometimes replacing small like John Deere and Kubota tractors, like very small ones.
Yeah.
So, but I don't think we're viewed as something that's like very small and not in. I guess we're viewed as something very small, so not threatening in any way to a Deere or CNH or Kubota. And I think what that means is that we're able to, I don't think we're viewed as a threat, which I would argue is a good thing. So the partnership really is, at this point, is just selling through dealership channel. There's nothing else formal beyond that, in my opinion. And then as an extension of that, we do partner a lot with other autonomy companies, however. So companies that want to do things like, I don't know, picking or pollination or scanning, or that realm, we certainly do a lot of partnership. But the larger OEMs, the Deere or CNH, don't really do any of that.
Can you give a little more clarity into how you might partner with some of these specializers around things like picking or whatever? Like, are you attaching some of their technology onto the Burrow, or they have like a software that might be kind of applicable, or how do you work with them?
Totally. So we probably have I guess it's probably 30 or 40 companies that are putting various things on top of Burrows. And so an example, we have a couple of picking companies. One is Fieldwork Robotics. They're based out of the UK. And I guess they're working on trying to commercialize harvesting of like raspberries and blackberries. And so their picking system, they mount to a burrow to do movement. Another example, there's a company called Weed It that does selective spraying. And I asked ChatGPT, what would a minion call a autonomous sprayer that's pretty small? And the answer came back, Sprayito. So we have a product we call Sprayito, which is Weed It mounted on a Burrow Grande. And that does selective spraying. And so we're not doing anything on top. We're just enabling a Weed It to be mounted on. And so there's you sort of think about what do people do when they work outdoors? They walk around or they drive around, they look at things and they do some sort of manipulation type task. And we do the walking around or driving around part, and we have a API and power and all those good things. And so with that, you can put a bunch of stuff on top.
Got it. I think, Tim, it was one of our earlier conversations. You talked about how you also help farmers decide what to have that year, or what type of crop to have, and you're using massive amounts of data, whether that's kind of satellite data or whatever, also soil data. I thought it was fascinating, and this is an example, I think, of how like these new tools can help farmers be much more precise to make and in what is a very tough environment, right? Low margin, oftentimes high degrees of failure. Can you talk about that?
Absolutely. That was a very, very nice discovery that we made as we were sort of going to market for the first time. Was we have these models that work excellently to understand what is the relationship between plant genetics, between a variety itself and the location there that's going to be planted in, and the management that's going to be practiced on it. And so the breakthrough was a genetic prediction model plus these other data sources can become not a breeding tool, but a variety selection tool. So, all the way back to when I was a plant breeding student, one of the first things you learn is genotype by environment interaction, which is that the best variety in one location can be the worst variety in another location. And the worst variety in another location can be the best. And if you want to trial things all over the world to figure out from your product portfolio as a seed company, what is going to be the best where and what should we give to farmers in one location or another, it's impossible. If you have 100 varieties and 100 locations, all of a sudden you have to do 10,000 combinations of trials to know what performs where, and 100 is way less than they actually have, and 100 locations is way less than they actually have. So this challenge is hard, but when we get data sources, we can have a model that understands it and then do digital twins where we say, here's a variety, what if we planted it in this farmer's field under their management, and here's a different variety, what if we tried that one? And then we can have a sense of, here's the top performer for where I'm sitting, and a different variety is the top performer where you're sitting. And that's been a very different tool, and it's exciting for us as a company because it brings value instantly. So we do have a problem in genetics and breeding, which is it does take time to release a new variety. Whether it's breeding or biotech, the improvement steps are set by biological timelines, and it takes years. And at Heritable, a big part of what we're doing is making it faster, but it's still years. Whereas telling a farmer or a seed company, hey, here's the variety that matches your field, well, that takes seconds, and that brings value instantly. That 1 or 2% yield gain I talked about in the beginning for corn and soy is based on breeding. But if you move a product to a different location and find it's a top performer there, you might get an instant 10 or 15% yield boost. So this has sometimes bigger impact on a
Mm.
much shorter timeline.
And hopefully revenue, another completely different line of revenue. And in a sense, if you journalize, you're a productivity acceleration and boosting company across both those really, rather than just kind of focus on one side like the genetics.
Right.
Go ahead.
No, I was just going to
Okay.
extend that out to these same models. We can run them backwards. So it's one thing to say, given this management, what is the best variety? But we can also say, given this variety, what is the best management? And this really applies for crops where you have multi-year um, growth perennials, whether it's a grape or a tree. And farmer might have their varieties fixed. They've planted 5 years ago, and they're going to have them for the next 15 years in the field. But optimizing the right management for those comes out of these same exact models too.
Charlie, we're hearing about how Tim's company is able to take all this data and help farmers and seed companies better plan to optimize for more productive growth. Are you maybe taking some of the data that you're gathering with some of your burrows and giving either real-time feedback or feedback over time where farmers who have a burrow can better plan? Like, because I can see how you could take the 600 or so burrows in the world, make your platform smarter, your model smarter, but also how can an individual burrow help a farmer be better in planning?
Yeah. Well, so I guess a couple thoughts I have. So, and I'll circle to your question, but I'll answer with an adjacent thing first.
Sure.
I think if you're looking at a combine in the Midwest, you're on RTK GPS, so your sub-centimeter. Your header as you're driving through the field is logging how much stuff you're actually harvesting on like a square foot basis. And then when you plant subsequently, your seeder can be changing fertilizer and the seed you put down on the fly based on where you are because it's perfectly geolocated. And so that's you have a real-time data stream that is enabling you to customize almost on a plant-by-plant basis what happens. And that type of stuff doesn't really exist a whole lot in the specialty crop realm right now. So I think a lot of what Tim is describing, or some of what Tim is describing, one thing works well here, not well here. That I think that level of customization will be enabled by AI and physical and robotics and time in a big way, in my opinion. Putting that aside, I think to your original question, we really are a mobility company. And so we really are focused on movement through the world and doing that well. And I think what we have found is that the expertise to do plant data and cluster counting and picking and all the thinking around that just is not our skill set. And so I think I found that we partner with a couple of companies. I think I know Bloomfield Robotics runs some stuff on top of our things at times. Bitwise, a bunch of like crop data companies that are really, really good at that realm. And I found that rather than trying to do those things ourselves, we tended to do best by partnering with folks. And then the final thing, I actually haven't seen a lot of crop data companies really take off yet in the specialty crop realm. I think what's missing is robot in the field, crop data, and then actual action tied in real time. If you just do one of those three things and not all in one thing, I don't think that it really takes off based on what I've seen. And in my view, circling all the way back to Disney's Wally, I don't think Disney's Wally is one company. I think it's a movement layer, which is Burrow. I think it's a perception layer with whether it's picking or pruning or weeding or spot spraying or whatever it might be. I think there's a perception layer for that, and there's a manipulation layer. And I think it's a couple of companies in one. It's not one single entity, in my opinion.
Yeah, that's interesting. I had a conversation earlier this week with Elliot Horowitz, who is the founder of MongoDB, and he's now doing essentially a robotics platform company that, because he saw that the world of software engineers oftentimes didn't speak the same language as hardware engineers. And that led to like a really big disconnecting, like fast iteration around robotics. And so he's trying to create essentially what I described as a WordPress for robotics. And now like, it's so easy now to spin up a website because all these different kind of layers through APIs, et cetera, have been tied together. And it sounds like I think we're heading that direction with robotics, where all the different layers of the stack will be tied together, which will lead to much faster and smarter and systems. And also to your point, Charlie, these may be different companies at the different layers, but I think through the ties together through APIs, et cetera, it'll just be better integrated.
Yeah. I guess I tend to like overuse analogies in Italy. I don't know what the right analogy for this point of time is in the robotic space. In my view, it kind of feels like maybe PCs in the late 70s, early 1980s, where you're going from like very vertical mainframe companies that like build the chip, build the tower, build the operating system, sell it directly, do all the applications. And we're suddenly at a stage where I think there's like, there's like someone's building the CPU, somebody's building the tower and the operating system, then like Adobe is building things on top. I think we're reaching a point where it's going to be layers across verticals as opposed to pure vertical companies. And so I do think that we're entering a realm where things are going to be more and more interoperable. And in that world, the more systems you have, the more customers are using them, the better your data set's becoming, and the more that someone wants to do something on top of it, the more you're able to sell. And so there's kind of this virtuous loop around scale at this particular point in time, in my opinion. So, yeah, and I also think that the future is going to be wild. Like robots in the future are going to be able to do so many things.
Yeah.
It's like, we can all see that like 10 years from now, robots are going to be everywhere. Like so many things.
Yeah.
And to me, the question is, how do you win now?
Yeah. We were just talking in the pre-chat about the Neo robot. For those who haven't seen it, it's like a new humanoid robot that will be available. You can rent it for $500 a month next year. And I'm like thinking maybe I should do that. Anyway, Frank O'Brien has a question, Charlie, that I think kind of as a follow on to what we were just talking about. And he says, is there an industry standard interface for connecting OEM devices from various sources, same connector and protocol, for example, from John Deere and Cat, or are they all proprietary? I guess. So I guess how standardized are we?
Well, I think on tractors, there are 3-point hitches, there are power takeoffs, there's isobus. So those are pretty standardized things.
Got it.
Operates. We are kind of right around like a Cat 0 3-point hitch. We do not have a physical power takeoff, but we do have an electric power takeoff. And then we have an API and pretty standardized connectors. So I would say that like in the particular form factor in which my team operates, we have a standard that's pretty comparable to most other companies, and things are pretty interoperable, although it still is early days.
Got it. I just realized I always forget this. I could bring the questions on the screen, which just makes it easier.
Oh, that's cool.
Yeah. So this is for you, Tim, and I'm going to read it through and let me see if I get this right. So Tiff wants to know, she's curious about thoughts on mutant breeding, genetic mutations with seeds. And this is part I don't understand, sent to space. And if this could be something in your future modeling. Do you understand what she's saying there?
Not quite, but I could speak to it. I'm going wide here, but when we listen to folks like Elon Musk, they're convinced that by 2040, half the planet's going to live in space. And bringing that down to Earth, it just represents you've got very, very different environments in space, on the moon, on a space shuttle. growing in no gravity conditions, whatever. We can adapt plants to almost any environment. They need oxygen, they need water, they need carbon dioxide. Uh, but but that sort of challenge of how do you improve a plant to match a very new environment is real today, whether or not it ends up being applicable for space. And so whether it's breeding or editing, uh, same same tools apply for making a plant ready for space as making a plant ready for northern Canada.
Yeah, it's interesting because space is by far the hardest environment, and there's a lot of companies, including many that participated in the Deep Space Food Challenge over the past couple of years that was put on by NASA and the Canadian Space Agency. There's also been work by the Japanese Space Agency, JAXA, on creating and kind of trying to facilitate startup activity to create food manufacturing systems for deep space. And then particularly in the Japanese side, they also had the dual mission of saying, "Oh, how can we then put this in the tarred spaces in the earth to create food in Earth?" Because there's lots of environments that almost match space and how difficult it is to grow food in the world. And so,
But if there's one thing I've learned since owning a company, it's that you need to go where there's a market.
yeah,
And Elon Musk's dreams of millions of people living in space aren't enough to want to convince me to take a risk on making plants for space. So
yeah.
um,
There is some more questions. Tim West, I know Timmy's a great guy. Tim, he asked, "What is the defensibility of the capabilities you're developing, or at least how are you thinking about defensibility of intellectual property?" I mean, this is something I think every founder thinks about. But I mean, in the Gen X side, the robotics side, imagine if you have a thought on that. I'll start with you, Tim.
sure. So the AI world is very interesting because lots and lots of defending approaches is not by patenting, but it's by keeping them secret. And so a big part of our strategy has been we we don't let folks see the tools we're using. And that can be a little bit complicated when we're dealing with a large, much larger than us seed company who they don't want to share their data. We don't want to share their code. The obvious in between would be let's all share everything, but we won't do that um, because we are not going to show our code to somebody who is motivated to use it. So keeping things secret is probably the tool we use the most. Second most is patents. We're patenting our models all the time. We have a patent portfolio. So whether we want to patent something and put it out there at
Mhm.
risk of it being used illegally, or so we can license it later and let other people use it. Those are our two main approaches to protect the models we have. And then on the plant side, it's much more straightforward. There's very clear regulations around what you can and what you can't patent when you've done an improvement. There's different types of patents. You can just patent the edit you've done. You can get plant variety protection on a newly released variety. So that's pretty straightforward and has been for several years, and we just follow that approach.
Charlie, hardware is a different market where there's all sorts of competitive cost concerns and like geographical manufacturing thing concerns. And so IP is also a big concern or thought, imagine, around what you're building. Can you defend your IP?
Yeah, totally. So I'll answer this kind of a funky way first. So I feel like I think so I personally was never like a great student in a way, and I find that personally I learned the best by making mistakes, and I think that an autonomous system is actually pretty similar. Like you learn the most by getting out there into the real world and making mistakes regularly at low cost, and then analyzing those mistakes and updating your system on a regular basis to no longer make them. And we track a KPI we call autonomous miles per user intervention, which I think is pretty standardized for many companies. We're at something like 27 to 30 miles per fault today. So we can drive, 27 to 30 miles per user intervention, and 99% of those flaws are robots stopping where it should keep going. So they're
That sounds
very,
better than a
controlled.
Tesla.
I don't know about that, but I mean, those guys are like gods of technology. But we're in our realm, though. You're going 4 or 5 miles an hour. You're a relatively small vehicle, so it's a pretty constrained in terms of risk. And so I think that, and we're 850,000 hours of autonomous operation. And so the first thing when I think about competition is how do you replicate that level of experience with a vehicle that processes 5 terabytes of data per hour of runtime per unit without doing it? And I think that I think it's just really hard to do. So first thing is we've made a lot of mistakes over 8 years of running at this point. Or it's like 8 years during which we've run 120 years of operation. And so I don't know how you replicate that without having an experience set. And the second thing, of course, we have a utility patent file globally. We have a lot of like IP in that realm. But I think that in the autonomy space, the groups with the biggest fleets are going to be the ones that win ultimately, because if you have the fleet, you have the data, therefore your product is better. Therefore, it's going to be hard for somebody who's a new entrant to replicate it. And then the final thing, I think it's very, very difficult. Actually, I think we're at this really weird point in time where so much venture financing is flowing into some companies. And I kind of start to question, like, if you have $1 billion tomorrow suddenly and you don't have any revenue and you have to build a company really quickly, do you yield a great company or not? And I think that one major source of defensibility for us is that when I sell a robot, I'm making money off that robot. And that means that I can scale in a more economically attractive way than some companies that don't have a really positive gross margin, basically. And so in my view, from to land the plane with 3 succinct things: one, we've made a lot of mistakes. 2, we have positive gross margins. And 3, we have a big fleet. And I think it'll be really difficult to replicate what we do without a big fleet.
That's interesting. Yeah, I think you have a great point in that massive amounts of venture funding oftentimes will corrupt your ultimate kind of mission, because the venture capitalists want returns, and oftentimes will result in weird business models, et cetera. And so there's more questions from the audience. Let's just get to them, because this is a great opportunity for these folks to hear from smart people in the space. And so this one's for you, Tim, again on the screen. Do you also have your own high throughput phenotyping platform to take data to train models to predict varieties for those traits, e.g. biotic or abiotic stresses?
Wonderful question. We do not. So the question is about, there's imaging approaches, there's other approaches that let you collect data from your plants at scale. And that is not what Heritable has chosen to focus on. It's a hard problem. I've been watching people give talks about precise phenotype from drones for probably 15 or 20 years. And it's moving forward, but I haven't seen a magic high throughput phenotyping tool yet. And so those are the types of data sets that we are using. They are always getting better, but we as a company are not focused on them.
Got it. Another question actually from Dave as well for you, Charlie. Do you have a robotic system that can take 3D data, e.g. disease on corn? Can you answer that?
Yeah, so I think we're not in corn. I'd say I grew up growing a lot of corn personally. I think that corn is, because it's so labor efficient, we've not seen it doesn't seem like a great place to start for an autonomy company today, in my opinion. So in a word, no, we do not have that. I don't see that being a realm that my team would enter into. I think it's so out of scope for what we do. It's super different.
But if I can jump in, I think what we are missing is the third company between Burrow and Heritable, which is a strap-on tool for the Burrow. You were saying that this is a mobility platform that takes other things. I had kind of expected that one place this conversation would go was, hey, Charlie, I'd love to use the data that you are getting off of your robots. And it sounds like actually we'd need that third company to come in and say, hey, we're the high throughput phenotyping company that sits on a Burrow and sends it to Heritable. Heritable does the decisions. We collect the data. Burrow gets us out there. I think that is the ultimate relationship that companies like ours are going to be in.
Yeah, Tim, 1,000% on that for sure.
And if, to your point, Charlie, if we really are in the homebrew computing club era of 1979, 1980, there's lots of opportunities for people to still build that third company layer in between. And so maybe someone listening to the audience today will do that. A question for you, Tim. Minakshi wants to hear about the Heritable mission? While adopting management practice on the field, do you consider sustainability, like regenerative practices, increased carbon sequestration, et cetera?
Absolutely. That slide I showed at the beginning of Brad and Davide running through the field, they were measuring corn roots to understand things like carbon sequestration in cornfields. Um, when it comes Personally, one of the technologies I'm most excited about that we are deploying right now is forest improvement through our through our tools. And what we can do with this is make trees better faster. And so if you go to a lot of forests around the world, the trees growing are not the ones that belong there. They're trees that have been moved there over the past tens or hundreds of years, species wise. The species have been actually moved because these are species that are more productive in these places, and that means that they're not resistant to the local pests. They're not resistant to long-term environmental conditions like droughts. And as we are improving trees, we want to get to a point where we are improving native species to be competitive with those um, invasive or transplanted species. We aren't currently deploying that, but those are the types of approaches that we are very excited as a company to be doing.
We have about 10 minutes left, and man, this could go on for another hour. There's so interesting, so much interest from the audience. I will say while we're talking over the next couple minutes, if you guys, Tim or Charlie, want to put some information in the chat where people can get a hold of you, I always like to make sure that people who want to continue the conversation or some way partner with you guys, make sure you put that into the chat so people can have that. One of the things we haven't talked about, I think, is always interesting is there's always a perception, I think, a generalization, an oversimplification about farmers in general being anti-technology, slow adopters, which I think couldn't be farther from the truth. And I think you guys would both agree. But the idea of like giving them their data, giving you their data, I think they're also very competitive business wise. And so can you talk about the reception you've had from farmers and working with farmers to maybe give the data that's gathered on the burrow, or maybe the data that might be gathered from the plants that you're using? How receptive have farmers been to working with you guys?
I'm happy to jump in. We have not worked with farmers directly yet.
Okay.
And
Or
that's
just in
because
ag in general, how receptive has the world of ag been towards working with you?
For us it varies very much depending on the partner.
Okay.
Our customers are primarily seed companies, and they range from small to very, very large. And the smaller companies have been much more willing to be collaborative about data sets that they are willing to share so that we can improve their varieties. We can't improve their stuff without knowing what the stuff looks like. So that's a necessary component of working with Heritable, is having some data sharing. And we've seen that small, mid-sized companies are very willing, and large companies are very protective. But it's we've gotten around that many times, and it's just a matter of being transparent on both sides about what our goals are and working out a contract that lets everybody get what they need from it. And on the farmer side, I just want to say, I think one of the barriers to farmers sharing data is that there hasn't been a compelling reason to. So I'm not going to share my data unless I get something positive out of it. And I think we will get to a world where companies such as Heritable are delivering real value to farmers, and then farmers will deliver their data back to be able to make those decisions. But it's delicate. And if we get to that, if Heritable gets to that point, we want to do it right, because we don't want to just take advantage of farmer data if we aren't giving them anything in return.
Charlie, I think you work more directly with farmers. Farms are buying your robots. How receptive have they been to deploy this pretty new cutting edge technology, and also maybe share their data with you?
Yeah, so I'll start with the technology part, and then I'll go to the sharing data part. So first off, I find that so I go into a typical customer for us will be, a 15 site nursery that's scattered all over the U.S. Every site will have, call it, 200 to 300 employees on the ground. And the irony we run into a bit is that they're the people that buy the product, and then they're the people that use the product. And those two people, those types of folks are very different. And so I found that with adoption of things, It's been very, very important to build something that it's a little humorous, it's easy to operate, it's easy to use, and it makes your life better as an actual laborer on the ground. And so, in that realm, like our robots are, the interface is in Spanish. We're going to soon have speech to robot, which I think that like talking with a robot just dramatically changes how you interact with it, in a really, really cool, vibrant way. So again, what I found from an adoption perspective is the group that you sell to is making an ROI calculation around how much labor do I save, and will the people actually run it? And then the people on the ground are the folks you really need to focus on the most to make sure that things work in an easy to use, easy to run, my life is better type of a way. Putting that aside, on the data side, I found that, and also I found that with end users or customers that buy our product, there's so much innovation and eagerness to try out technology. Like I think farmers and growers are testing stuff out constantly.
Yeah.
And so I have not found it to be a space where there's resistance to technology. I think it's actually one of the most, it's a very high adoption rate on technology from what I've seen. Secondly, I think your question about data, to me, data is, I think it depends on how close that data is to the core IP within a company. I think to Tim's point, like I think if I were to go into like a large grape grower or a large nursery and do a lot of really close, high resolution imagery of the plants that they grow, I think that would raise alarm bells for sure. But what we do right now is all of our data is around movement. So it's all around like mobility, and
Yeah.
I've not found that anybody cares about that really at all.
Yeah.
So with that, anytime if a robot makes a mistake in Australia and drives through some weird spider or something, that data set goes back to us and subsequently it's labeled, and the next model goes to all robots globally, and nobody has ever seemed to have a problem with that type of data flow. I think if the whole fleet gets better by virtue of a robot making a mistake on your site and all learn to get better for it, that doesn't seem like it like nobody particularly cares about that.
Yep.
I do think as data becomes much higher resolution, like we're like digital cameras in 1990 right now, right? It's like, it's 320 by 240 pixels. That's really low resolution. I think 5 years from today, 10 years from today, we're talking about like a vehicle that drives around that is sucking all of the information from the world into like a digital twin simulation environment and is able to do manipulation, a host of other things. I think as we get to that world, data is going to become a lot more valuable and proprietary, but we're not there yet.
Okay. If you guys are okay, just going a couple minutes over because there's some questions. Sounds like you're okay. Because I want to give these folks who asked a chance. So this one's for you, Tim. Could you tell us more about how you guys do or overcome boundaries related to integration of multi-omics data for breeding prediction? You probably understand that. I don't, but you probably understand the question.
Yeah, I do. So yeah, omics are all of these data sources. You've got genomics, we all know that one, which is sequencing DNA, and then transcriptomics, which is looking at what is the RNA or the proteins being generated. And then you have proteomics and all of these different sources of data that look a little different. And then phenomics, measuring lots of phenotype data. We could keep going, and people have so much fun with the omics term that there's a professor, Jonathan Lynch, who likes to talk about shovelomics, which is going out into a field and digging things up with a shovel at a large scale, very non-robot approach. It's human. Anyway, the point is these are different types of data sets that are traditionally challenging to integrate, but I challenge the audience to open up Cursor or Chat GPT or Gemini or whatever you want and ask it to integrate to messy data sets, and take your bank statement from 1 month and integrate that with your yearly bank statement from the last 10 years. Like, these things don't naturally fit together, but they can be fit together, and generative AI is so good at it. It's reformatting data, making data sets match is, in my experience, one of the biggest magic tricks that just those traditional AI models do. So that is how I'd answer is integrating data is one of the most straightforward tasks for any AI model. And then when you have more complex data, you do it in a more complex way, but it's very achievable because of the new breakthroughs.
And this is, I think, tying together your world of being a professor at some point and now an entrepreneur. But Samuel wants to know, since you've been in academia where there's pressure for publication, how do you reconcile this pressure, which makes us want to publish something before anyone else, with the possibility of having a product that can be commercialized? Is this something you've wrestled with?
I haven't. So the reason I haven't wrestled with that is because when I was in academia, I was 100% not interested in commercializing anything. That was just, I had a very open attitude um, towards science, and all of my code I would release. At one point, I worked for the U.S. Department of Agriculture. I was going to meet with one of the big seed companies, and they were going to put me under NDA, and then the USDA said, "Tim, we have to put you under NDA. What are you going to tell them that they can't know and share?" And I said, nothing. I had this fight with the lawyers. I said, everything that I'm going to tell them is either on my website today or will be published in a paper very, very soon. But, they still made me come up with something. So anyway, that was just who I was at that time. I wasn't interested in commercializing. Now I'm on the company side. I had a few entrepreneurial experiences over the last 5 years that made me realize that this is a different, exciting, fun challenge. And so now I'm trying to, instead of publish a paper, publish a product. And that personally has been an exciting switch, but I can't speak specifically to how I reconciled those because they're sort of different chapters of my
Yeah.
personal life.
All right, we're wrapping up here for both of you. Any final closing words? And maybe also, is there any type of company or type of someone out there listening you might be interested in working with, or a need you may have? I'll start with you, Charlie.
Yeah, so I guess I'll say I think that there's a huge need for autonomy and physical AI outdoors in a lot of these industry. Yeah, like I don't know, in vineyards and nurseries and berry operations in the grain outdoors. There's so much need for this technology. And so I would ask that if anybody is looking to do something like picking or pruning or weeding or spot spraying or crop data or just data generally, any of those types of things, we're eager to collaborate and are totally open to mutually selling a solution set you might work on in that realm. It's really just like if you want to build those types of things and you want to place them on top of a burrow, we are very keen to support and help however we can. And then final thing, I do think the future is going to be wild. I think we're at this very, very unique point in time where like 10 years from today, robots are going to be everywhere. And to me, the space is like Mount Everest in 1952. Like it's big and it's there and nobody's done it yet, but there are going to be robots everywhere in the next 10 years in a really, really cool way. And so looking for collaborators in any form around that.
Great. Tim?
Yeah. So on the collaborate side, really seed companies in niche crops, fruits, vegetables, trees. This is where we are focused right now. And we've been very excited to see that even though traditionally people say you need to do corn and soy if you want to have a market, we're proving that that is completely wrong. And it's a lot more fun to make improved food than it is to make improved feed or fuel. So that's where we are on the collaboration side. Soon farmers, large scale farmers today we'd love to work with, but we're not yet at the point where we have a pin drop for small scale farmers. Then on the future side, it's data, it's all data, and it's very exciting to be. I mean, every day I wake up and learn about a new data set that is either public or becoming available, or there's a way to get it that just makes our models smarter. We're using, hundreds and hundreds, or maybe even thousands and thousands of variables at once. Things like weather and soil type and temperature, and then you name it, we're using it. And we keep learning about more. And to what Charlie said, in a year, there's going to be more data sources. In 3 years, there's going to be more. We talk about phenotyping things from drones. One of these days, we're going to be phenotyping things from satellites. So phenotyping is collecting measurements. And so it's just an exciting time because I know it's going to be very different in 2 or 3 years than it is today.
Thank you both. This has been really great. Our audience really enjoyed it. and you guys will be able to watch the replay over on the Spoon. So, Tim, Charlie, thanks again. This has been
Thank
great.
you.
Yeah, thank you. This is fantastic. Thanks.
This was really fun.
All right, guys, stay on.